go live. There you go.
Where are you going?
Lágídí kọ́ ló lọ fi change iná. Ìgbà tẹ́ tọ́jú ẹ̀ tí jẹ́ ń kú ẹ̀ dẹ̀ gbé padà sí NEPA irọ́.
Ṣé mo pàjá ni?
Ta ló pàjẹ́?
Bàbá Tolu.
Ẹ́
Bàbá Tolu.
pẹ̀tọ́
Hello, class. Good morning. I can see some asking on YouTube whether class has started. No, class has not started. I just wanted to make sure that people connected on YouTube. So I'm watching now. Indeed, they are connecting. So in the next 2-3 minutes, we will start. Please don't just join on Zoom and keep quiet. Please help others that could not join because the capacity is filled up already, 300 on Zoom. So the rest are heading to YouTube. And remember, the YouTube number is by far more than Zoom. So please help share the link I posted on our chat now on the Zoom. Share the YouTube link, please. YouTube, I think I wrote YouTube. That's a mistake. Just YouTube link. Thank you. So in the next 2-3 minutes, we start. And for those on YouTube, please say hello if you can hear me clear on YouTube.
Off your video. They know the type person now. Why you show your face?
All right, good morning, class. We met last week and we started our lecture 3 on computer software. And before then, you had done computer hardware. So today we'll be looking at computer processing modes and computer networks. But before that, let's have a very quick recap of what we did last week. That's on computer software generally. So we told ourselves what computer software is, set of rules and instructions, telling the computer what to do and how to do it, if I put it that way. And we looked at the two classifications of computer software, system software and application software. We are told what the difference is. One seems to take more care of the computer itself. The other one seems to take care of the user's own tasks. That's the application software. Then under system software, we looked at the 3 classifications there again. I hope you still remember them. One of them is utilities. Another one is operating system. And the third one is something. And so I hope we are reading them, reading our books. We discussed on what operating systems are and what the other 2 are, and the little differences between them. But at the end of the day, the 3 of them are system software. Under application software, we talked that they are the software that help perform specific tasks. That's generally speaking. Then we looked at programming languages in a brief. And the programming language, we looked at high level, low level. Why some are called high level, why some are called low level. And examples of high level, examples of low level. At least there are only 2 examples of low level, which is the machine language or the binary code. The second one is the assembly language. While under high level, you have most of those languages you hear every day: the Python, Java, C++, C#, JavaScript, etc. And I remember telling us that they are called high level for a reason. They are closer to human understanding. We believe that the human understanding is high, so they are closer to human understanding. And indeed, if you look at the text of these programming languages, you see that you'll be able to, even if you're a coconut head, you'll still be able to say, okay, this thing they're saying here is integer. This thing they are declaring here is function, etc. But in low-level languages, it is very abstract, zeros and ones if you are dealing with machine code. Or if you are dealing with assembly language, you are talking about mnemonics, about signs and symbols used. So it's very difficult to, if you convert your name in assembly language, you will say, God forbid, this is not my name. But system, that's your name. So that's generally what we did last week. And I strongly urge us to always read our books, read our manual, also Google whatever we are interested in with respect to this course, and read to understand more. So don't be like the guy that goes to church only on Sundays, or the guy that goes to mosque only on Fridays. No, you'll always pray. You always be in the state of holiness. Let me put it that way. I'm not pastor, I'm not preaching, and I've never been a pastor. So same with your studies. You will always be in the mode of preparedness, not just on that Tuesday, 8 o'clock, you'll be disturbing me for link. After that, you disappear, you go and enjoy your life, and or maybe disturb other lecturers for link. Then another Tuesday again, you come and disturb. So read, and the secret is always read relatively after the lectures, so that whatever the lecturer said, except about mind you, of course, will still be fresh on your head. So today, we'll be looking at computer processing modes and computer networks. There are so many things to say, and it's a little bit challenging to understand than lecture 4 from software. But still, it's not rocket science. Still should be able to grasp what we are saying. And where you are not able to, if you read your manual and other literature sources, you should be able to follow up. Remember the rules. I've muted us for obvious reasons. You know the reason. So that display wouldn't be Oshodi market. That's 1. And 2, so that there will be concentration. There wouldn't be any distraction. Then 2, If you have questions, always pass through your course reps. And last week, I received some questions and I was able to answer them. Some with delay, some immediately. So feel free. If I'm lecturing, you have areas to ask questions, but you can't ask them, write them down so that you don't forget later. You can put it across to me through the course rep. So that's that. Nothing else to add. So on today's lecture, I'll remove my video now to save some money. We are going to talk about computer processing modes. And you know what they are? What are we talking about when we say computer processing modes? These modes define how a CPU, that's a central processing unit, how a computer operates and manages access to system resources. They define how a CPU operates and manages access to system resources. By system resources, I mean something like memory, memory allocation, power, security in the system, that's in your computer, and other resources. So these modes depend on which mode you're talking about. It has limited access. Some gives you just surface access, some give you deep, some give you total access over the system resources. So the modes also refer to different ways computers process data and execute tasks. So when you talk about computer processing modes, it's also referred to as CPU modes. So you see, it is central to CPU, central processing units. That's computer processing mode. They are also referred to as CPU modes. They detect how a central processing unit functions by what? Determining the level of access it has to system resources. Of course, we have the most common modes being the user mode. We'll see them shortly. But the most common is the user mode for regular applications. You have the kernel mode, or we like call it supervisor mode, for privileged operations by the operating system. So they essentially define which instructions the CPU can execute and what memory areas it can access, depending on the current mode. So next now, this is just a brief introduction. Then computer networks. Of course, we look at computer networks. Computer networks is what? An interconnection between two or more computers, two or more devices. There is a reason why we are interconnecting them. You did not just interconnect them because you are running mad. No, you are interconnecting them so that they will be able to share resources. Computer networks I'm talking about. So computer network is an interconnection between two or more devices. At your level, I will say between two or more computers, but actually it should be between two or more devices because a printer can be connected in a network. I'm sure you have been in the office where a guy in his office printed something and the printer printed it out in another room. That means that printer and his system are in the same network. So computer network, for the final time in the briefing stage, is an interconnection between computers for the purpose of sharing resources. And those resources could be many. One, it could be your printer they are sharing. It's a resource. It could be data, information, files, systems, etc. So that's a brief. So next now we are going to look at examples of different computer processing modes. Now the user mode. That's one of them. If you check your manual, these are what are listed here. A user mode, so I will just talk on them briefly. You can see there is no text you have there. It's just them listed. So you will have to do what? Listing carefully. Listing and listing. All right. 1 minute. I'm coming. Give me a second. All right. Now the user mode. The user mode is a restricted mode. In which applications run with limited privileges. It's user. So user wouldn't have so much privilege. You are just a user and you are not the owner of that system. So it's a restricted mode where applications run with limited privileges, preventing direct access to hardware and critical system resources. So in a user mode, there's little or no access to hardware and critical system resources. And under user mode, you are dealing with limited privileges. The applications run with limited privileges. And this is the standard mode for applications where access to sensitive system functions is restricted. So this is the standard mode, user mode. I will also say that the user mode is a restricted execution environment where user applications and processes run. Restriction is the key word, ladies and gentlemen. So in user mode, programs have limited access to system resources and cannot perform privileged operations, such as accessing hardware or modifying system settings. Those privileges are absent. So that's for user mode. The second one is what? Kernel mode. The kernel mode is a privileged mode, unlike the user mode. This mode allows operating systems core. The operating system's core is called the kernel. It allows it to execute with full access to system hardware and memory. So when the CPU is in kernel mode, it has full access to all system resources. Full. And it can execute any instruction, allowing your operating system to perform privileged tasks like managing hardware or allocating memory. So this is kernel mode, unlike the user mode. Now you have the next one, rail mode. We call it a legacy mode in x86 processors. You don't need to cram what is x86 processor. You'll also see it in your manual there called x86 processors. Just processor, kind of a processor then. So that mode provides direct access to memory and hardware used in early DOS systems. So rail mode is the simplest operating mode of x86 processors, and they offer direct access to memory, input and output devices, and even the hardware. So as I said, it is primarily used in early computing systems, such as MS-DOS and early versions of Windows. So that's for rail mode. So what you take away here is mostly dealing with early computing systems. Early is the keyword there. MS-DOS, DOS systems, and early versions of Windows. See, I've been using the word early. So if you're the cramming type, so you can easily cram this. The next is protected mode. Protected mode is an advanced mode. I think it was also introduced in early Intel processors. Was it in 1980-something, 82? It enables features like memory protection from the name, protected mode. So this mode enables features like memory protection, multitasking, and virtual memory. It was introduced in the 1980s, and it is used in all modern multitasking operating systems. The next is supervisor mode. It's a high privileged, very, very high, from the word you can see. So at work, your supervisor is the organ. So it's a high privilege execution mode, allowing the operating system to manage low-level hardware functions and system calls. So what does this mean? It essentially means that it allows the running program, usually the operating system kernel, allows it complete access to system resources and hardware, thereby enabling it to perform sensitive operations that regular user applications cannot do. So it means it essentially gives it the highest supervisor, the highest level of control over the system. The highest, that's your key word there, level of control over the computing system. And then the last, not the least, the SMM, system management mode, from the word management. So you see that it's going to manage something, Abi. So it's a special mode used for power management, system security, and kind of firmware level functions triggered by that SMI, system management interrupts. Well, you don't need to cram this. It's all about management. It's a high privilege operating mode on the same x86 compatible processors and used for low-level system management functions like power management, hardware control, where the code runs with elevated access. And that access is completely transparent to the operating system. Okay, each of these modes plays a critical role. They play a very critical role in maintaining security, stability, and performance in modern computing environments. So we need to know them. And the easiest way to go about it is to pick one or two keywords about each, so that during exam, you will come out smiling. Not when you fail, you come out and say, sir, my system was not working well. The mouse was not shifting well. That's why I failed. When you knew that you did not read. All right, so that's for now, the most common computer processing modes. I wouldn't say it is the only, but the most common computer processing mode. All right, next. Go into data processing. From the word data processing, it will sound like you are processing something, which is data. So data processing is, let's say, the process of collecting and manipulating data to produce useful information. Some call it meaningful information. So it is a process of, collecting and manipulating data. By manipulation, we mean, doing something with it with the aim of getting something useful, something you can interpret, something you can use. For example, when you go to the ATM machine, you type in your PIN code, you select the action you want to take, withdraw, and you get your money. You see? When you typed your PIN code, the system collected it, played with it to give you access. That access, is that useful stuff. You now get the access and get your money. So it's the process of collecting and manipulating data to produce useful information. So it's a process of changing information in a way that can be observed. And there are some steps in data processing, which is very simple. Even if they wake you up, no, I ask you to say, you'll be able to. Collection is the first step. You must collect the data. You must gather the data from sources, like data lakes and warehouses. Then you must prepare that data. That is, by preparation, I mean cleaning the data and formatting the data to make it accurate, consistent, and usable. So this involves checking for errors, duplicates, missing data, etc. Then inputs. You will now input the data into a computer using an input device like your keyboard. Data is the processing. After the raw data, you now process that data after it has been inputted. You alter that raw data to create usable information. Then the output is you are presenting the processed data like graph, like visual stuff, like a diagram, or like text, or a display on your screen. These are all outputs. Then you save the processed data for future accessing, if the need be. So the takeaway here is, what is data processing? That is about gathering and manipulating data, not just manipulating it, but the aim is to get useful information, meaningful information. And these are the steps there. You can close your eyes and guess them. You have to collect it, prepare it, then input in this computer, process it using the computer, get your output. That's all. And then you can store it where the need is required. Right. Okay, so I move on. Next, types of data processing. So I will quickly talk on each of them here, but each of them has a slide dedicated to them. The next slide now you're going to see is about batch processing. The next one will be real-time processing, etc. So let me briefly talk about the types of data processing here. as you're seeing it on your screen. When we talk about batch processing, data is collected over time and processed in bulk. That's why it's called batch, at a scheduled time. These are at least the three characteristics of batch processing. Let me repeat. Data is collected over time and processed in bulk at a scheduled time. So I will speak more on that when we move into batch processing proper. Examples is your payroll processing, bank statement generation. I will speak on that later. Second one is real-time processing. The word real-time. So it means something is being processed right there when you are inputting the data. So data is instantly processed as it is received. The ATM machine, as you are typing your PIN code, it is processing it straight away there. There are other examples like the online banking transactions. If you do transfer, that transfer is going straight away. You have your stock market trading systems and the rest. The third one, online processing. Some call it, or it is also called online transaction processing. It is similar to real-time processing, but it typically involves multiple users accessing a system simultaneously at the same time. So similar to real-time, but you see the difference now, multiple users. So the example is your e-commerce websites, your airline booking systems, those that always fly from Ogun to Lagos, even if there is no airport there. Number 4, distributed processing. Whenever you hear distributed in your life, especially in the terms of computer, it is talking about systems that are geographically in different places, but they seem to be performing one task. You know, the general task is shared into small sub-tasks. So each system tries to perform its own task for the aim of getting the general task. For example, you guys, I know we are cramming this formula of board mass, brackets, of, division, multiplication, etc. So if you have a arithmetic task that involves board mass formula, I'm just using a local example. So under distributed processing, if you have 20 computers, working under this architecture distributed, each computer might take care of one arithmetic function. One computer might take care of the multiplication, another computer might take care of the division, another might take care of addition. But at the end of the general aim is what? To get the answer. So under distributed processing, data is processed across multiple computers or servers in different locations. That's why I say geographical locations. Example, cloud computing, blockchain transactions, etc. For real-time processing, time sharing processing, the last one on the screen. Here, multiple users share processing power simultaneously, and each user gets a time slice. Multiple users share processing power, share the CPU resources at the same time. Each user gets a time slice. For the first 0.01 seconds, CPU will perform this task. After that, CPU will stop, even if the task is not performed, moves its resources to another task. Example is mainframe computing and the early computer systems. So this is a brief of all these. So shall we now move on to looking at each of them more deeply? Shall we? Can one say yes on the chats? Okay. This must be a Chelsea fan. All right. Batch processing. So I've made things a little bit easier for you. This is what we are going to see now. See batch processing. Let me move to the next. Real-time processing. The next, online processing. The next, time sharing processing. The next, distributed processing. So each has a slide. See where we started. So I'm moving now to the first one, batch processing. So listing, although some of these, you can also read it more online or on your manual. Okay. Real-time processing. No, sorry, batch. Batch processing, I've already told you, collected, processed in bulk at a scheduled time. So it's a data processing method where large volumes of data are collected, stored, and processed together at a scheduled time. I've still repeated all those characteristics. Are collected, large volumes of data are collected, stored, and processed together at a scheduled time, rather than being processed immediately. This method is efficient for repetitive tasks that do not require real-time interaction. So characteristics of batch processing, as you can see on the screen, one is delayed execution. Data is processed after a certain period. Remember, we said scheduled time. So data is processed after a certain period or when a specific condition is met. Automation, too. Under batch processing requires minimum human intervention once the process starts. By minimum, there have been some classes where I said it requires no human intervention, but I've changed it to say minimum human intervention. So batch processing requires little or no human intervention once the process starts. So that's why it's automated. Efficiency. It handles large amounts of data at the same time, thereby reducing processing costs. That's where the efficiency came in. And sequential execution, the next. Tasks are executed in a sequence, often based on priority. Then the last one, error handling. This is the last but not the least. There are other characteristics of batch processing. And you should be able to, that's what we call knowledge. You should be able to, based on explanation of what batch processing is, come out with other advantage characteristics. So error handling, errors are usually detected and corrected in a later batch run. So I haven't said that this is positive or this is negative. I'm talking about what is characteristics. The errors are usually detected not when the current data batch is being processed, but in a later batch run. So examples, payroll processing, employee salaries, that's number one there. Employee salaries are calculated and processed at the end of each month. Abi? When your daddy comes back smiling at the end of the month, know that he has been paid. Or when your mom comes back, or somebody, at the end of the month, salaries are processed, right? So there is a system processing that batch. And let's look at whether it meets the definition of batch processing. The staff details are collected. Maybe somebody has gotten promotion, somebody was demoted, somebody died, one thing or the other. So all those details are collected, large, and then processed at a later time, at a scheduled time. That's at the end of the month. So you don't get your salary every day. So at the end of the month. Bank transactions too. Banks process multiple transactions overnight. Multiple transactions, I mean, some stuff like check clearances and the rest. So these are done overnight. These are at a scheduled time. And this is large volume of data being processed together at a scheduled time. So I'm using the definition of batch to explain these examples. Utility billing. Your electricity for those that pay light, not those that are tapping it, illegally. Your water, your phone bills, they are all generated in batches at regular intervals. You'll be sleeping, you wake up, see alerts, thinking that it's good alert, you will see their debit. And you'll be wondering, when did you buy anything? When you look closer, you now notice that this was a transfer debit. For transferring money, debited 50 naira. And your eyes was seeing 50,000. So this was not done immediately, you see. Maybe in the night or at a particular scheduled time, the banking system, without human intervention, launched that automated system, and it was able to calculate and bill you appropriately. The other example, so data checkup. Companies schedule daily or weekly backups of their data in batches. Sorry, data backup, sorry. So you can back up large data in daily or weekly backups or monthly. Then inventory management, retail stores especially, they update their stock levels at the end of each day. So if you check very well, that updating, that's batch processing. There are advantages. I will go quickly on it. It's not on your screen. I expected, to carve out advantages and disadvantages of batch processing. The first one, it is cost effective. It reduces the need for continuous manual supervision. That's what I will say there. The second one is time saving. Batch processing processes large volumes of data at once, thereby minimizing system load. The third one I will say is less processing power. Why? Batch processing can run during off-peak hours, thereby optimizing your resource use. Another one I can remember is consistency. It ensures standardized processing across all data. Now you process this today, tomorrow you process, everything gathered, then you schedule their processing at a later time. Now, disadvantages, just few I can remember. Okay, someone said I'm very fast, but the lecture is being recorded. It's being recorded, so at the end of the day, you will still get it. Not somebody saying you can join YouTube. Apart from joining YouTube, this lecture is being recorded, just like last week's lecture, and I shared it, and I believe most people got it. So in case, I'm fast, I understand. I might be fast to some people. It is normal. It is very okay. You shouldn't be ashamed of that. Everybody have their rate of understanding. So it is very, very perfect. So that's why that video is being shared. I did not share it so that you love me, no. It's to help you go through the video again, wherever you believe you did not get correctly. But I think so far, much of what I'm explaining, I didn't get it from the sky. They are generally on your manual. But in the manual, I must confess, it is not stated like this. So the lecture is trying to streamline and structure it well to guide you. And when they call me, Dr. Woyi, it's time to bring set questions. I will set questions based on my own parts. And definitely, I'm going to set questions based on what I'm saying, what I'm teaching. So don't be afraid. I'm not going to set questions that I never talked about in this class. But if you offend me, I can throw in 1 or 2 questions, sure. Heavens will not fall. Okay, for disadvantages, there are also many, but let me just talk about 3. Delayed outputs. Now, number 1, results are not immediately available. Well, it is delayed output, so it's a disadvantage. 2, I would say difficult error handling. Why? Errors may not be detected until after processing is complete. You see, when you're dealing with large volume, and the error might not be detected until after processing. Until after I've received my salary, I will now go back to senior building, salaries and wages unit, and say, sir, this is on my side. Should 5,000 is missing. What happened? Say, oh, it's true. Don't worry. Next month we'll add it. So that error is normally detected at the end of the processing. And the last one is batch processing is not suitable for real-time needs. It's unsuitable for applications requiring instant updates, like your online transaction. You wouldn't want to send your boyfriend 5K, and then the money he will receive it after 3 days. So batch processing is not suitable for such real-time needs. So that's for batch processing. So we move on to the next, real-time processing. So you can see I've arranged all these in a way that, will be a little bit easier for you to understand. Okay, let me quickly look at the slide. Person are writing me, sir, please, can we get your slide? Don't be distracting me with questions. Yes, Omale, Rachel, you can get my slide. And I shared my first lecture was last week. And I shared the slide, and I also shared the video, the lecture, this lecture now, the Zoom recording. I shared it. So does it mean that you did not get it? Omale, respond. Does it mean that you did not get the previous one? If you did not get it, reach out to your course rep. I'm aware that there is a COS 101 course rep group where I post both the link to this lecture and also link to the recorded and also my slides. So if you don't get it, reach out to your course rep. You should be able to have it. I shared last week's own, so if VC is on this lecture now, you'll be wondering, is this man not sharing his lecture slides? I do share, and you'll also get this. But remember, what you get on the slide is, bullet points, but the talking, the explanation is coming from me directly. So that's why you also need to listen very well. So real-time processing, the second one, from the word real-time. It sounds like, please, may we stop putting down matric numbers? This is not secondary school, okay? This is not a place where you just be in your house, be sleeping. You just log into the lecture, type your matric number and go back to be sleeping. Oh, it is me that has no time that will come and be gathering fake presence and whatever. No, now. So if you want to remain in peace and sleep. If you're at work, walk. If you're going somewhere, go. No wahala. Don't be disturbing me with matric numbers. I will not ask of it. Although I was told not to tell you that I will not collect. I will not collect. Let me tell you now. So if you like, don't listen. If you like, don't attend. Another secret is, even if the video is given to you, trust me, it is always easier. It is always more convenient to be at the lecture when it is going on than later to say, I will listen to the video. You might not have that time, trust me. You will not have that time. Chemistry will send their own. Computer will send their own. Physics, what do you call it now? Bio 101, biology. We send their own. I will now see that it will be hard for you to be concentrated. So it's better you read now. And we know, not me, we know how to deal with those that are not in class. We know the questions, you will see them. You go read your slide, the tire. But if you did not listen, you might not get that score you are looking for. So please listen very well. And stop all this matric number you're sending me as if I've been in the system for years. So I understand how it works. But it is when you're in year 2, year 3, maybe we see now, you must attendance. And some of the lectures are physical. So please just calm down. Stop all this matric number. Last lecture, one course advisor, these are the people that attended class. And they look and they laugh. Oh, these are the people those that bribed you or those that did not bribe you that attended class. So just keep it, relax. So that's for my own lecture. I'm not speaking for any other lecturer. I'm not speaking for any other course, but for my own lecture. So that you wouldn't go and say that, Dr. Wo, you say that we shouldn't be taking attendance. All right. Real-time processing. Real-time processing is a data processing method where data is processed immediately, where data is processed instantly, immediately, instantly. That's the word, as it is received. So as you're receiving it, as the system is receiving the data, it's processing it immediately, providing instant or near instant output. This method is essential for time-sensitive applications. This is another keyword, ladies and gentlemen, for time-sensitive applications. This method, real-time processing, it is essential for time-sensitive applications where delays can impact operations. Characteristics are also on the screen. 1, instant response. It processes data as soon as it arrives. 2, continuous input and output. Data flows in and out without delays. 3, high reliability. Systems must function with minimal errors or downtime. I always use the ATM machine or your online banking transactions. It must function with minimal errors. You don't want to be like when you want to transfer money, you are encountering errors many times. No, yes, once a while when you transfer, it show you error, maybe your money no complete or money is complete, but one thing or the other led to error. But you will hardly see error continuously for 1 week. So real-time processing systems are known to be highly reliable. 4th one there is concurrent processing. It supports multiple users or systems at a time. Low latency, it reduces processing time to, milliseconds or microseconds. There are many examples listed there. Let me just pick 1 or 2. Online banking transaction, because it's about money, and you guys like money. So by online banking transactions, I mean, your fund transfers you do, bill payments when you pay for MTN or pay for something via your banking app, and the rest. Another one is, let me pick another one. Number 3 there, traffic control systems. Adaptive traffic lights adjust based on real-time congestion. You might not know what I mean by adaptive traffic lights, but some of you, and I know there are quite a number of you who have traveled abroad to Europe or to US, they use adaptive traffic lights. Not the one that you see in Sabo as you are leaving, like you are leaving Yaba heading to Third Mainland. That's Sabo Junction. That red light there, to me, is useless. The red stays for long. And when it changes to green, before you can say Jack Robinson is gone back to red. Adaptive traffic light, by that I mean traffic lights that, they use AI to see where congestion is. So if it's on a junction and one particular route, how will I put it, like 2 roads intersected to form a junction. So one of the 2 roads, if it is highly congested, the traffic light will adapt itself such that the green light facing that congested road will last longer, while that which is not congested will last shorter. Maybe that's peak hour. During the evening, things might change and the traffic light will also adjust. So you see, it's real time. It's happening at that time. It's getting information, processing it, and reacting. Which information is it getting? It's getting the picture of the road, whether it's congested or whether it's not congested. So that's a traffic light. Another one is fraud detection. Credit card company detect and block suspicious transactions instantly. Online gaming, hello to the multiplayer game lovers. Multiplayer games require instant data updates for seamless gameplay. You are playing, the guys will know what I mean by those playing FIFA. Well, FIFA is not a good example, like Counter-Strike, all these war games that you are playing in a team. So each team, like in your team, you guys are 5, for example, each person knows the function he or she should perform, and you are using your earphone to communicate. So you tell him, John, please check, or wait, somebody is coming. John will have to hear it that time and seamlessly. Else, John, before he will hear John, wait, they have already shot him on the head. So in online games, communications there are almost instant. Then others, weather monitoring, sensors track and update climate data in real time too. These are just some of the examples. Advantages are there to one, immediate decision making. These are the ones I believe you should be able to track. Immediate decision making is essential for critical applications like your healthcare or finance applications. If it is a device that is monitoring your heart or monitoring whether the lungs are functioning, or if it is an accident victim, they put so many marks on it. So that machine is taking decision every second. Of course, real-time processing systems are known to offer better user experience because it's fast, it's responsive for users. And you will agree with me that you and I, if you are dealing with a system on your phone, you're pressing something and it's responding immediately, you'll be happy and happier. Then you press and you wait. What is happening? Is there internet or is it not working? What is the error? What is the fault? There's also increased efficiency. Why? It reduces wait times and enhances automation and others. Improves security, detects fraud, cyber attacks, and other anomalies instantly. Now, there are disadvantages. One is high cost. Most real-time processing systems require advanced hardware and software for continuous processing. Most of the real-time processing, they are not moi. They really are advanced, and they require advanced systems to ensure continuous processing. And when I say advanced system, of course, it's going to be expensive. And 2 is that it needs complex implementation. Real-time processing needs robust system designed to handle simultaneous data streams. And the 3rd one is error sensitivity. And by that, I mean that any system failure can disrupt operations. So that's for real-time processing and Mortal Kombat. Yes, so that's the name, Mortal Kombat. Is Mortal Kombat still existing? I played it a lot while I was in the university abroad, Sha. Here, who they give you computer? I played it a lot. It's a team Mortal Kombat. When we are bored, we move on to go and play Mortal Kombat. Then we later moved on to FIFA. That was so bad in FIFA. All right. Somebody asked, I can't be entertaining all questions. Here is airbag real-time processing, sir. Since there is a space between that air and bag, you have to explain to me what you mean by that airbag. What do you mean by that airbag? Can you quickly write it? Or should I just move on after we check? If those writing the matric number will allow airbag, do you mean the airbag on your car? If it is, then yes, you're absolutely right. It collects information. What information? Impact, a very hard impact on the front of your car. And it processes it and interprets it as an accident. And therefore, it produces useful information, which is that, boom, airbag that comes out in front to protect the driver or the passenger from hitting his or her chest on the car. So yes. All right. Next is online processing. It's also called online transaction processing. And whenever you hear online processing, one of the key words that should come into your head is internet. Internet, at least, must come into your head. So online processing is a method of data processing that uses the internet and computer equipment to process data in real time. It is used to respond to user input and process transactions. I know some questions when I arise, what is the difference between online processing and real time? It's a little bit challenging to explain it to non-science students. One is real-time processing might not use the internet. It might be just their application. If you go to ATM machine to type, you are not using the internet, you are using the network of that bank. You see? But in online processing, internet is key. Internet is there. And the online processing is used to respond to user inputs and process the transactions. So internet is the key word there. So in this method, data, in this processing method, it's a processing method where data is entered as all other processing methods, processed and updated in real time, typically through an interactive system that allows multiple users to access and modify the data. So it's a data processing method that uses the internet and computer equipment to process data in real time. So this captures the three key features of online processing. In real-time processing, internet was not mentioned there. The characteristics are also shown on the screen. Instant data updates. Changes are immediately reflected in the system, just like in real-time processing, but this with the use of the internet. User interaction is 2. Users actively input, retrieve, and modify data. When you're dealing via the internet, users are actively inputting, retrieving, and modifying data. And of course, the third one, it grants many users access. It supports simultaneous access by multiple users, via the internet. This is online. It's database driven because it often relies on databases to store and retrieve data efficiently. So the data that multiple users will be using is stored somewhere in the internet. So, and that somewhere is database. And high availability. When you talk about high availability, is it always available? Can you log in anytime in the night to type cnn.com and the website will open? Yes. So the internet generally is highly available. So systems must be operational 24/7 to handle user requests. So any system that is implementing an online processing behavior must be available 24/7 to handle user requests. So the examples are your e-commerce transactions, Websites like most of you go to Amazon. Some don't have the money, but they just want to go there, look at products there, be happy, and leave. So a website like that, Amazon, process orders and payments instantly. But it's online, so it's internet. You access that Amazon via the internet. And Amazon is able to process your order instantly, as if in real time too. Now, the banking systems, your account balances update immediately after a transaction. When you send out money, it is updated, your balance is updated immediately. Somebody is requesting to record to their computer. No, it is declined. I'm recording it in my own. If you want to record it in your own and go and sell it, Abi, and make money. So I will not pick all the examples there. Hotel and airline reservations. When you book a hotel or your flight, that your booking system allow real-time reservation and cancellation. You don't book and say, okay, thank you, received your money. We'll look for a seat for you tomorrow. It is instantly, this is done. It sounds like real-time, but then this is done via the internet. So the rest, customer relationship management, POS, retail store processes sales transactions instantly. Online learning platforms, students can take quizzes and get instant results. So any online learning platform where you can take a test and get your results immediately is an online processing system and the rest. So there are some advantages and of course disadvantages. Some of the advantages is faster decision making, just like in real time. It's convenient, being that users can perform tasks anytime and anywhere. It's automated, meaning that it reduces manual intervention and improves efficiency. Scalability is another advantage because online processing systems support multiple users and transactions simultaneously. So like Amazon, 1 million users can access it at a time. 3 people can access it at a time. 3 billion people can access it at a time. So it's scalable. Some of the disadvantages is, of course, just like in real time, both of them, have similar advantages and disadvantages. Disadvantage one is high infrastructure cost because it requires powerful servers, databases, and security systems. The CNN website you go to check or the unilag.edu.ng site you all are trooping to check for registration, for information, for whatever. We are operating it with powerful servers, and those servers will always be on 24/7. Therefore, trust me, those servers are not cheap at all. Dependency on internet and power is another disadvantage. So that means the downtime can disrupt operations. If you don't have internet or NEPA no day, and that server is being powered by NEPA, that means when you type unilag.edu.ng, it will show error. It can't open because the server where the website is hosted is down because no light or down because no internet. And the rest. Now, 2 to go. Distributed processing. Give you 1 minute to look at it. Sorry, while I cough a little, I'm having some cold. And I think it's Man U fans that did this, so that I will not remember them today. No wahala. So 1 minute, look at what is on the screen while I cough a little and blow my nose small. All right, good to go. Distributed processing. By the way, I have a question. And I would prefer you two people to be answering that. Since they are online, they can quickly check. Look at your age, everybody. Some were born, you guys are very young. You guys were born in 2000 and something, I guess. Most of you was born in 1990, 2000 and something, if not all. Now look at your age. Since you were born, have you ever seen Arsenal win any cup? If you have seen, let me know. Well, let me put it this way. Have you ever seen Arsenal win the Premier League, Because if I say any cup now, some of you will go and craft a cup and say, it's a C cup, they won. I've never seen, and I've been wondering why. What happened? Is it that they swore for them or what? Arsenal fans, don't be angry, because after Chelsea, my second club actually is Arsenal. Really, sincerely, no joke. My second club is Arsenal, but man, I've never seen them win a cup since me was born. Since I was born, talk less of when you were born. And I don't know why. So the only pain point is they always drag London with us. So Chelsea fans, kindly tell them, London is blue. It is not red. Arsenal should go and be dragging second place with Tottenham and the rest. London is blue. So whenever they are ready, they should go and carry Champions League, carry Premier League. Then they will come. Let's talk. But for now, let them just keep quiet. I'm saying this because one Arsenal fan wrote me, sir, this, that. If you check all the time Chelsea and Arsenal met, Arsenal has upper hand. I don't know, but what I know that you people have not carried Champions League. When you carry, come and talk. So if you have answer to whether you have ever seen them, let me know, please. So, but remember, London is blue. And it will remain blue even if we are playing nonsense. All right, let's move on. Jokes apart. Distributed processing. It is what? A data, once you hear distributed, remember, geographical location. That's one of the key points. It's a data processing method where multiple computers or servers, often located in different geographical locations, work together to process data. This approach improves efficiency, ladies and gentlemen. It improves scalability. It improves fault tolerance by distributing tasks across multiple systems instead of relying on a single machine. How I wish you guys at 300 level. This is one of the questions I would like to ask. It's a question you have to explain. That distributed processing systems improve efficiency and scalability. Can you explain that? When systems are located in different places, each one is performing a little task that will contribute to the general task. Of course, you can see efficiency will improve, scalability will improve, because each will perform to its best way than relying on one single system to do everything. What if that single system fails? Okay, so it is distributed processing is used to improve the speed, efficiency, and reliability of data processing. The characteristics are on the screen for you. Decentralized computing is one of the very well-known characteristics of distributed processing. Decentralized, because tasks are spread across multiple nodes, across multiple computers, across multiple servers. 2, parallel execution. Multiple tasks run simultaneously, improving speed. You have 10 systems that make up that distributed processing system. So one computer is doing another task, another computer is doing another task. They are all doing this task at a time. That is what we mean parallel execution. The third one is fault tolerance, which I've already explained a little, that if one computer fails, if one node fails, others continue processing, thereby reducing system downtime. Unlike when you have just one central computer, when it fails, now bye-bye. Scalability, I said I would like to ask if it is an essay question. What do I mean by that? New computers, new nodes can be added to handle increased workload. So if the workload is increasing, you can add in more computers to that system. Fifth one, resource sharing. Computing resources like CPU, memory, storage are shared across multiple systems. So each system comes with its CPU. Another one comes with its memory. Another one comes with its storage. They are all shared. Examples are there. Cloud computing. I don't know. I think most of you should know what is AWS. It is from Amazon. Amazon Web Service. It's a cloud computing service from Amazon. You also have Google Cloud. You also the rest. They are all cloud computing. Data is processed across multiple cloud servers in these systems. 2 is the blockchain networks. I didn't want to talk about this so that you're not going to, spend your money on cryptocurrencies. So, but cryptos like Bitcoin, they rely on a distributed network for transaction verification. Those that are into Bitcoin, they know what I'm saying, that this network relies on distributed, this system relies on distributed network for transaction verification. You have your search engines like Google, Bing, the rest, web crawling and indexing. They are distributed across global data centers. Then you have distributed databases, systems like Apache, Cassandra, Mongo database. They store data across multiple servers. So you see, everything I'm saying is multiple, across distributed. Online multiplayer games, I've come again, Mortal Kombat people. Game servers, they distribute processing loads to ensure smooth gameplay. It's not just one server that is ensuring that everything is going fine, you're playing your game. There are so many servers. Then big data analytics, large data sets are processed across multiple nodes. We have advantages, disadvantages, just like I've mentioned others too. Improved performance is a key advantage of distributed processing. Why? Because of parallel execution speeds up processing. When every system is doing a work at the same time, the processing will speed up. That's why I said improved performance. Scalability is also there, number 2. Systems can grow by adding more nodes. That distributed processing. Fault tolerance, I've already talked about that when I was talking about characteristics. If you look at characteristics, some of them are advantages, actually. If you look on your screen, characteristics, some of them are advantages. So fault tolerance, scalability, they're all there. Resource optimization, it utilizes computing power efficiently. And geographical flexibility, users can access distributed systems from anywhere. There are disadvantages. One is just like in online or even real-time processing. One is complex implementation because it requires specialized infrastructure and software, to ensure that, all those distributed systems understand each other. Data synchronization issues. Keeping the distributed data consistent can be difficult. All the systems handling the same data, making that data consistent across them will be sometimes challenging. Higher cost. So whenever you hear about cost, you're talking about the equipment or the internet service that you have to pay for. But here, higher cost means you need more hardware, network infrastructure, and maintenance. You are dealing with, if you have like 100 distributed systems working as a whole, so you need more hardware now. The systems, that they are the hardware, and network infrastructure to make sure that they work as a whole. So these are the advantages I can remember for now. Until further notice, we move on. Somebody saying that London is red, Liverpool is red. Go and read geography. I wish I can cite your, what do you call it now? O-level result, JAMB, WAEC or NECO. If you did geography, trust me, that geography you got F. Seriously. Because Liverpool is not in London, okay? Liverpool is in Ijebu-Ode. That's where they are, not in London. There is a town called Liverpool in UK. That's where Liverpool is, not in London. London is blue and blue. Liverpool, go to your own area. Go and drag it out with your neighbor there. Man you. The final one, time sharing processing. The name, time. So it seems something is sharing time. I'm just trying to make things easier for you to remember, understand. When reading it at the comfort of your home, it's easier. But when you are under exam conditions, you go see now, we'll meet at DLI. That's where your exams will take place. Come and sit down there. Your mouse is not working. Get away, my friend. Why are you wearing this car? Where are you putting this type of dress? Blah, blah, blah. These things can disorient you. So, but when you sit, remember, that man said time share, I should think of this. You will do. After you come out and come and dash me something. Say, sir, take this one, drink. You said so, and it came out. But if you fail, don't look for me. So in that time sharing processing, time sharing, we are talking about a situation where multiple users or multiple processes share the same CPU resources. I've not called anything time, right? Multiple users or multiple processes share the same CPU resources by dividing processing time. into small time plots. You might not know how CPU works. CPU is the brain of the computer. And as your system is on now, as your mobile phone is on, the CPU is dealing with thousands of processes right now. So it allocates its processing time to each, it allocates small time slots to each of those processes. It handles this process a little, it pauses, goes to another, it pauses. So this time sharing I'm talking about. So each task gets a brief moment to execute before switching to the next. So time sharing is a computing technique. It allows multiple users or multiple programs to share a computer's resources at the same time. So it's a way to efficiently use a computer's processing time by dividing it into small slices or intervals. The characteristics there on your screen, the examples are there on your screen. The multi-user system means what? It allows multiple users to interact with a central system. So if some of these, I don't need to explain them. I think you understand them. What do you call it? The name is self-explanatory. Okay. CPU time division. The CPU allocates short time slices to each task. It's another characteristic. Fast switching. The system quickly switches between tasks, ensuring responsiveness. Interactive computing. Users receive quick responses to their inputs. And priority-based scheduling. Important tasks may receive more processing time. I repeat again, time sharing processing is a computing method where multiple users or multiple processes share the same CPU resources. They share the same CPU time by dividing the processing time into small time slots. So it's a technique. It allows multiple users or multiple programs to share a computer's resources at the same time. The examples are operating systems like your Linux, macOS, iOS, Android, Windows, and the rest. They manage multiple applications running at once. Yes, open your phone, many applications running there, those that you know and those that you don't know that are running on the background. Your operating system is a time-sharing processing system. We have others. The mainframe systems are mostly used in banking, airlines, and large enterprises for simultaneous access. Cloud computing services like your Google Drive and other cloud computing services, they allow multiple users to access shared resources. Once you send something on Google Drive, many people can access it. But the processing power, enabling that's where we come into cloud computing. You have your others, online databases, virtual machines, educational computing labs, etc. Most of them have spoken something about them before, so I don't need to explain them again. For advantages, I will just mention them, no need explaining. 1, efficient resource utilization. 2, multi-user support. Multi-user support, many users can work on a system at the same time. 3, cost effective. It reduces the need for separate hardware for each user. What else? Fast response time. It creates an interactive computing environment. Error isolation. If one task crashes, others continue to run. That's the little advantage I can remember. Disadvantages. Remember, you have your manual, always go through. Security concerns. Shared access increases the risk of unauthorized data access. So that's a major issue. Security concerns. Resource contention. Too many users may degrade system performance. Too many. And complex system management. By that, I mean it requires efficient scheduling and resource allocation. And this is complex. CPU overhead is also a disadvantage because frequent task switching can slow down processing. When the CPU is frequently switching from one task to the other, this can slow down processing speed. All right. So let me put it this way. I've come to the end of the first part of this lecture, which is bigger parts. The second part is just 2 slides, but the talking there is just too much. And I'm having headache, I'm having catarrh, I'm having everything. If I had known, I wouldn't have touched you guys. I would have just concentrated on asking our people. Now I don't know what they did to me to ensure that I will not talk. So we are moving to the next. Let me go to the very first slide to guide you on how we are moving. This was the very first slide. We talked about computer processing modes. Now we are moving to computer networks. This is the second part. It has just 2 slides, but those 2 slides will take up to 30 minutes of talking. So computer networks. Think for a minute what you believe is a computer network. What do you think is a computer network? I think for a minute and see. What you think is a computer network. I didn't say you should answer, just think. All right. Now, computer network, short sentence, I will explain it with. It's a system of connected devices. I said this at the beginning of this lecture. Connected devices that can share resources and communicate with each other. A system of interconnected or connected, anyone goes, devices that can share resources and communicate with each other. They are not just interconnected, but there is a reason why they are interconnected, for them to be able to share resources. The only question we ask, what's our resources? Resources I've mentioned, one can be a printer, or the normal resources, files, data, even memory. Do you know, if I connect my computer with yours, and everything you do, I can configure it so that you'll be storing it in my own computer. Everything, your file, your PDF, your slide, store it in my own computer. Not that you have access to my computer, but since they are connected, you can configure such that whatever you are doing there is stored on my own memory. So that is also a resource. We are sharing memory and other stuff. So a network, always remember, it's a set of, or a system of interconnected devices that can share resources and communicate with each other. And those devices use a set of rules. Those rules are called communication protocols. So these devices, they use these rules to transmit information over a physical or wireless connection. So another way I can explain what a computer network is that it's a system of interconnected computers and devices that communicate with each other to share resources, to exchange data, and to provide services. And those networks can be wired or wireless, and they can vary in size and complexity. That's the next slide we are going to look at. There are types based on size and complexity, from small home setups to large-scale global infrastructures like the internet. All right. So let me pause a little and go and take care of those on YouTube. Remember, they are by far more than you guys here on Zoom. So by taking care, I want to make sure that everything is flowing on well there, that they are not fighting, and that they can hear me very well. So permit me, I have to stop this share later so that I can view my browser where the YouTube is running. So I will stop for a minute to go check on them. So the YouTube people, if you can hear me, say yes, we can hear you, please. Just say, let me move on. Say yes, we can hear you. All right. Yeah. Somebody's saying YouTube don't die. I hope YouTube people. Okay, you can hear me, right? Okay. Please don't fight. So it's remaining 30 minutes. I will be the referee, but I will wear Chelsea jersey and be the referee when you start fighting. So don't fight now until after the lecture. Please listen. Jokes will always be jokes, and lecture and business will always be business. So having confirmed that the YouTube people can hear us, you can see they are by far mean than on Zoom. So let me go back to Zoom to continue sharing our slide. So 1 minute. come in. Let me share back. Okay. So having described what computer network is, ladies and gentlemen, it is what a system of interconnected devices that can share resources and communicate with each other, that can exchange data, and that can provide services to each other. Okay. So we move on to the next, and the next one is so tiring. I'm even afraid to dwell there for the next 20 minutes. This is the slide. I'm going to dwell there, but I will be fast, really. I can't come and kill myself, really. Okay. If you check your manual, I know that these types of computer networks are listed, and I know that they wrote little things about them. So the little things, I will talk about it now. I don't know whether they talked about characteristics. They should have talked about characteristics in that manner. So I will look at them. We'll look at them quickly, each of them. You have the local area network, the wide area network, personal area network, intranet, extranet, cloud computing network. So what is a local area network? It's a network that connects computers and devices within a limited geographical area, such as a home, your office, school, university campus. So it allows users to share resources like files, printers, internet connections efficiently. So resources, I've given you other examples of resources. Internet connection is a resource, files is a resource. So local area network, whenever you hear about LAN, is talking about a limited geographical area in your house, office, school, or university campus. There are characteristics of LAN. I don't know whether I should just dwell into that or leave it for you to read manual and get them. Let me start with LAN. But as I'm moving on, if I see that I'm not meeting with time, I will just be explaining what they are and leave the characteristics out. I will tell you to now go read about them. Characteristics of local area network, I just have like 3 I can remember. One is limited coverage. It is common sense when I said that LAN is a network that connects computers and devices within a limited geographical area. So characteristics of LAN, one is limited coverage. What do I mean? It typically spans a single building or a small group of buildings. Number 2 characteristics is high speed. LAN is known to have faster data transmission compared to the larger networks like the next one we are going to check, WAN, wide area network. So it's faster. And what else? Wired or wireless. So local area network, they use Ethernet cables, not internet, Ethernet cables. That's wired. Or Wi-Fi, a wireless LAN. Then another characteristic is centralized management. That is LAN, local area network. They are often controlled by a network administrator, often. So that's it for local area network. We move to wide area network. It's also a telecommunications network, but spans a large geographical area, often connecting multiple smaller networks such as the LAN itself or metropolitan area network. If you see where I'm hovering on the screen, the one in the middle, it can connect the one on the left. It can also connect the one on the right. So the wide area network, they are much larger than metropolitan. They are much larger than local area network. Wide area is larger than metropolitan. Metropolitan is larger than local area network. So wide area network, they span a large geographical area. And they are used for communication, data transfer, resource sharing between distant locations, including cities, countries, or even globally. So if I say they are used to share resources, that should not be a big news for you. Every network is to share resources. The key features or characteristics I can remember there is 1, common sense, large geographic coverage. It connects devices over vast distances, unlike local area network. Another one is, what can I remember? Varied ownership. It can be owned by organizations or rely on third-party service providers. then public and private infrastructure. This wide area network, it is known to utilize leased hired lines, hired satellites, hired fiber optics, and public networks like the internet, for it to be functional. And others. So let me leave it there. The third one is metropolitan area network. The name too, metropolitan. It's a network that covers a geographic area larger than local area network, but smaller than wide area network. So it typically spans, let's say, a city or a large campus, and it connects multiple local area networks to create a larger network infrastructure. Number one characteristic is, again, geographic coverage. It covers an area ranging from, let's say, several kilometers to a citywide scale. Number two is it interconnects multiple LANs, multiple local area networks. So it acts as a bridge between multiple LANs within a city or a region. For ownership, it is owned by organizations or service providers. It can be managed by governments, by corporations, or by service providers. That's for metropolitan. Okay. Next one. Someone said I should describe computer network again. Computer network is what? An interconnection of two or more devices for the purpose of sharing resources. You are interconnecting two or more devices so that those two or more devices will be able to share resources among themselves. And what are resources? Files, printer, other data, storage. One computer might have a very small memory. Another one will have large memory. So whatever the one with small memory is doing, it can store it in the one with larger memory, provided they are connected. So computer network is a system that connects computers and other devices, not only computer. Printer is a device, server is a device, router is a device that interconnects them. For which purpose? For the purpose of sharing resources. Okay. Personal area network, PAN, the fourth one on the screen. It's a network designed for short-range communication. The name personal. So it's typically within a few meters around an individual. So it connects personal devices such as your smartphone, your tablet, your laptop, smartwatches, and whatever, wearables. So for your personal use. Key features, one is small coverage area. It's usually within a range of 1 to 10 meters. So you can imagine, very small. Low power consumption is another characteristic because it's optimized for energy efficiency. And the third one, which you should know, is wireless and wired connection. Personal area network can use stuff like Bluetooth, Wi-Fi, USB cables, infrared even to connect. And that's what I can remember now for personal area network. The next, the names can even sell them out. Their names, see their names. Next one is campus area network. Campus is already there, the name. So it's a network that connects multiple LANs, multiple local area networks within a limited geographical area, such as a university, a corporate campus, or a military base. And it provides high-speed connectivity between various buildings and departments. So one of the features is multiple LAN integration. Remember I said campus area connects different buildings or departments within a campus. And those buildings might represent local area networks on their own. You have centralized management. That is another feature. CAN, that's campus area network. It's often managed by a single IT department for security and maintenance. And there are others, key features of a campus area network. The next is home area network. So it's a type of, all these I'm mentioning, they are on your manual, so I did not just bring them from the sky, they are on your manual. For home area network, it's a type of computer network that connects devices within a home. So it enables, come on, your exams are going to be what? OBJ. So it is a very big sin if you fail. Questions coming out from here, from this kind of stores whose name are all self-explanatory. OBJ that you have A, B, C, D to choose from. So if you fail, pack your load and go home. Write a letter to Unilag and say, I'm sorry for getting admission. I'm sorry for taking the spot for other people. I'm going home to my house to go and take another job. So you must pass exams that are CBT coming from this, at least from these topics I'm covering today. If you don't pass, knock yourself on the head. Go to Jeleba, enter car and go home, please. Because you have no right to fail. These simple things. Yes, the grammar is small, but the names are home area network. I said it's what? It's a type of network that connects devices within a home. Will you go and fail? If you fail, don't eat for 10 days. Just be doing jogging, frog jump for 10 days if you fail. After doing the frog jump, pack your belongings, go home. Well, yes, I know that all of you are at home now, but during exam, you are coming into campus. So, home area network enables communication between various digital devices such as computers, smartphones, smart TVs, all those devices in your home, tablets, gaming consoles, smart home appliances. So the key features, one is it's also wired and wireless connection because it uses Ethernet cables, Wi-Fi, Bluetooth for communication. 2 is device sharing. It allows sharing of resources such as printer, storage, and internet connections. And it, of course, enables smart home integration, supports IoT. You know what's IoT? Internet of Things. So it supports IoT devices like smart thermostats, security cameras, voice assistants, all those stuff. And then, of course, local connectivity. It covers a small geographical area, typically within a home, because it's a home area network. The next is wireless local area network. If you check the first one, it was local area network. Now it's wireless local area network. So it's going to be local area network, but that is implemented in a wireless manner. So it's a local area network, sorry, that uses wireless communication to connect devices within a limited geographical area, such as home, office, school, public space. It's just the definition of what? Local area network, but it uses wireless communication instead of using physical cables. So instead of those physical cables, you use wireless LAN, rely on radio waves to transmit data, typically, following some IEEE standards, if I will put it that way. So key features, 1 is its wireless connectivity. 2 is limited geographical range. 3 is multiple access points. 4 is scalability. That's the 4 I can remember now. Features of wireless local area network. The next is a client-server network. This client-server network, from now on, these are not like types of computer network, but since it is how it is written on the manual, let me just flow that way that is a type of. No. In a local area network, you can have a client-server network. In a wide area network, you can have a client-server network. In a metropolitan area network, you can have a client-server network. But as the case is, let's follow the way it's written on the manual. So client-server network is a network architecture where multiple devices called clients request services or resources from a centralized system called server. Multiple devices called clients request services or resources from a centralized server called server, from a centralized system called server. Let me give you an example, a very typical, useful example. When you open your browser and you type unilag.edu.ng, the website of Unilag will open, University of First Choice. If your friend also type the same thing, it will open. If 500 of your friends type the same thing on their own different systems, it will open. What is happening? You and your friends, you all are clients. Your system is a client. But the server, where that Unilag website is cooling its head, the server where that website is hosted, that is the server. So all of you and your 500 friends are the clients making requests to a server to get something. In this case, to get Unilag websites. So that is a client-server network for you. And there are so many of those kinds. If you type CNN, this is also a client-server network. If you are downloading something, a video from the internet, or you want to download a video from YouTube or from whatever, this is a client-server interaction. You are the client. The video where that thing is stored is the server. The place where that video is stored is the server. So it's a client-server interaction. This model is commonly used in businesses, in educational institutions, in large organizations to manage data application and network resources efficiently. In banks, I open my app, UBA app, you open your own UBA app, another person, we all are accessing the same place. So we all are clients, and that place, the machine we are accessing is the server. So key features from there, one, well-known, is what? Centralized management. The server controls access, security, resource distribution, centralized management. Another one, two, key feature, very funny, multiple clients, same feature. Many client devices, you and your 500 friends, the PCs, the smartphones, the tablet they are using to connect to that single server. We also have another feature, scalability. You can easily accommodate new clients and resources. Dedicated servers is also another feature because servers handle tasks like file storage, authentication, database, and applications, etc. So let me leave it that way. The next one is the P2P network. I don't want to pronounce that PEER. So let me grant you 10 seconds permission to speak. Everybody, if you want to speak, you speak. You know what? That's PEER. Sometimes it's hard for me to pronounce. My tongue is construed so that I don't pronounce it sometimes well. So I will let you, the good English pronouncers, pronounce it for me. But in computer science, we say P2P and move on. You know what P2P is. So I will make you rehearse a little. So you can unmute yourself. You can shout the pronunciation. Let me see how you pronounce it.
Peer-to-peer.
P2P, P2P, P2P,
Peer-to-peer.
P2P.
Peer-to-peer.
Peer-to-peer network.
I've heard you. It is P2P, I know. I mean, that's PEER, to PEER. That's what I want you to pronounce. Let me hear it very well. All right, go ahead.
Peer-to-peer.
Peer-to-peer network.
That means I'm pronouncing it well. So why am I shying away? Peer-to-peer, that's what I call it. But when I call it, there was a time the students said, we thought you are calling the peer they sell in the market. You know, the normal avocado peer. So I was confused. I said, okay, my mouth, sure, let me just call P2P. Look at it on the screen and know what to, know what I mean by P2P. But in computer science, we call P2P. You know what it means. So peer-to-peer, it is like the opposite, or how will I call it? A brother to client server. In client server, everybody making requests is called client. Anybody providing answer is the server. I repeat, in client server, every device making requests. You want to see the website of Unilag. Your computer is making requests, so it's the client. The server is the one that will respond to your request. And server might not be one. CNN, do you think that CNN has one server? Do you think that Google has one server? Do you think that Microsoft has one server? No, they have thousands of servers. So if you type Microsoft.com, your request might be directed to a server in California. Your friend seated beside you type the same Microsoft.com, her own request might go to a place in New York, a server in New York, but it's the same company that owns them. Now in P2P, there is no server, PC. Let me put it that way. But we have this question for our 500 level students. Sometimes they get it confused. That in P2P, do you have a server? Do you have a client? They will always say no, since they are all peers. Peers means I can serve as a server. I can also serve as a client. You can serve as a server. You can also serve as a client. But in client-server architecture, server is always server. Client is always client. But in P2P, both can. So in P2P network, I would say it's a decentralized network where all the connected devices called peers, they share resources directly without relying on any central server. So if you have 10 devices, call them device 1, 2, 3, 4, 5, 6, up to 10. Their name is device 1, device 2, device. So device 1 can make a request to device 10 and get what it wants. That device 10 can also make a request back to device 1 to get what it wants. So unlike in client server, where the server is always the server, the client is always the client, here, anyone can serve as a client and server. So in P2P networks, the clients are also servers. So how do you know which one is server? How do you know which one is client? The one making requests is the client at that time, and the one supplying response is the server at that instance of time. But immediately that request response is done, then everyone becomes a client again and a server again. So each device acts as both a client and a server, and therefore allowing users to share files, computing power, and other resources efficiently. So the key features, one is decentralization. Unlike the client server where the server is there and everybody's making requests, in a P2P network, there is no central server. All devices communicate directly. The nodes are equal. Every device can act as both a provider and a consumer of resources, so they are equal. Scalability is there. Number 3, it's also a key feature. More devices can join without significantly affecting performance. So if there are 10 devices making up that P2P network, 20 more can join, 100 more can join. They all are interconnected, no central server. The next one is resource sharing. Users can share resources. And I've been talking about resources. Resources could be many things. It could be computing power. It could be memory. It could be other resources like power supply, etc. All right. Okay, no problem. Sorry, somebody distracted me a little. Okay, another key feature is fault tolerance. How I wish you guys are few. I could have asked that question. What do you understand by fault tolerance for P2P network? But because of time and because of I don't want to have a market, in client server, if the server fails, wahala dey. But in a fault tolerance, if we are 20, one fails, the others can still be exchanging information. The others can still be sharing resources because everyone can act as a server and also as a client. But when you have a client-server network where server fails, there is problem. So that's P2P. The next one is intranet, not internet, intranet. It's a private network, ladies and gentlemen. It is used within an organization to securely share their information, resources, and communication tools. Like in banks. Banks, they have their own network. That maybe you have UBA here in Unilag, you have another UBA in Yaba. The managers, they communicate through their network. They don't use their phone to be calling each other. They have a secured network where only them can communicate. They have a secure network where they can dish out assignments to the staff. So each staff is required to connect to that network and see what is going on there. So it's intranet. It's within an organization, to securely share information, to securely share resources, to communicate, securely share communication tools among employees. So intranet, the keywords, keywords there is what? Private network, or even the more keyword there is sharing among employees. It's a secure network to share resources and the rest among employees. It is like the internet, a place like the internet, but it is restricted to authorized users. Intranet, anybody can have access to internet. So it's like the internet, but the difference is it is restricted to authorized users, making it ideal for internal collaboration and data management. Key features of intranet is 1, restricted access. Only employees or authorized users can access it. 2, internal communication. It provides messaging, forums, and announcements for teams. So in that UBA network, you'll be getting announcements, forums, and other messages. And there are other features like resource sharing. In that network, you have internal documents, database, and software that authorized users can use. You have another key feature is security and privacy. That network is protected with firewalls, authentication, and encryption so that not anybody can get access to it except employees and the rest. So this is a feature of intranet. The next one is extranet. I know you are tired, the same screen, and we have been speaking grammar. The next is extranet. Why I didn't bother putting up a write-up? There are many. If I put up a write-up, it will be so many. So since you have your manual, you get it there. And I hope you still have the manual. The last lecture, you told me that it has finished, and I told the HOD supplied. And I think I have information from my medical lab students that they have been buying. I don't know. So try to get them. Extranet. It sounds like the intranet. The extranet is just the intranet. However, it allows external users to have access. External users such as business partners, suppliers, and customers. For example, I use the UBA network as an example that allows only the employees. They can configure the network such that their contractors, suppliers, or partners can have specific access or can have access to specific documents or specific resources in that organization. The access employees will have will be more than the access these third parties will have in that network. So I will say that the extranet extends the functionality of intranets by enabling secure collaboration with external entities. Did you understand my explanation of extranet? That the extranet expands the functionality of intranet. It grants limited access to third parties. And those third parties is not just you and I, but to the contractors, to business partners, to suppliers, to even customers, to that intranet. When you go into your browser and go into your, let's say, UBA banking site, there are some things you have access, but there are some things you might not have access, but employees will have access. So you are somehow granted access to their intranet. Or will I put it, you are now on the extranet because you have access. But inside the extranet, you have intranet that is only accessible by the staff of that business, of that company. So key features there, restricted external access, secure communication is there, collaboration and data sharing, just like in intranet. But the collaboration here under extranet is what? Collaborating with your business partner, with your suppliers, with your customers, sharing stuff like documents, exchanging documents, project management, supply chain integration, etc. Another feature of the extranet is controlled user permission. Different users have different levels of access. Employees have a different access. Third parties have different access. Okay, that's the few features I can remember now of the extranet. Now, second to the last, the virtual private network, VPN. You guys know about VPN? If you have lived in a country where there are where most sites are censored, like in China, for example, I think this Facebook does not work there. YouTube that you guys are enjoying is not there. It is not there. The authorities block access to it for one reason or the other. So people use VPN to bypass that blockage to have access. Same, for example, in US, at the moment, crypto is not allowed. But with the coming of Trump, things might change. Crypto is not allowed. So if you want to open any crypto app, it will not open. At least I experienced that. Stores like your Bybit and Binance, they do not open. But if you connect to a VPN, virtual private network, it opens. How? I don't know even how to explain that VPN for you. So I'll just leave it because you are not 200, you are not 300 level students. But VPN tries to hide your identity. and it rather shows its own identity to whatever you're accessing. You want to access Binance, and Binance knows that it is banned in US, that it is not allowed for US citizens, for US residents, and you're in US trying to access it. Once it sees your IP, this IP is from US. No, we block, because we don't want the government to punish us. But if you use a VPN in US, VPN will cover your IP address. So Binance will not be seeing you that you're in US. It will be seeing that you are in Japan, that you're in Nigeria, those countries where they are not banned. It will be seeing that this IP address is from Congo, is from Russia, places where it is not banned. And so it will grant you access while you're in US. So that's VPN. So that virtual private network is a secure connection that encrypts internet traffic and routes it through a remote server, allowing users to access web privately. So it helps protect sensitive data. It helps hide your IP address, and it helps bypass geographic restrictions. That's VPN you always hear about. There was a time, what was the name of this app again? It's now X. Before it was called what? Twitter. As was the time it was banned in Nigeria, but some people were still using it, accessing it, using what? VPN. So when you access it, Twitter will see IP address not coming from Nigeria. It will see IP address coming from, for example, US. So it will grant you access, not knowing actually that you are in Nigeria. So one of the features is encrypted connection. It uses protocols to encrypt and secure your data. IP address masking is another feature. IP address masking, you already understand what I mean by that. It hides your real IP address to enhance privacy. Another one I can remember is secure remote access. It allows employees to access company networks safely from anywhere. And another key feature, funny one, bypass geographical restrictions. It enables access to content blocked in certain locations. So if a content is blocked in certain location and you are there in that location, you can still access that blocked content via VPN. Okay, the last one, congratulations to us, is cloud computing network. So it's a system of interconnected servers and data centers that provide computing resources, storage, and applications over the internet. So instead of relying on local servers or your personal computer, users can access and manage data remotely through cloud service providers. Most of you are subscribed to cloud providers, like Apple has their cloud. Microsoft, which is very popular, also has its own cloud. They have cloud services, meaning that you can store your files there, go and sleep, knowing that they are secure and safe. Now, storing your cloud where? What is that where? Of course, layman will say it's in the cloud, but actually these are heavy, complex servers that are running 24/7, morning till night. These servers are interconnected to make sure that whenever you want to view your stuff, your documents, your files, or whatever, or a video, you always have access to them, or your applications. Some servers also are used to store applications. So instead of running your application on your phone, just go to your cloud, run the application there and use it. The key features is one, scalability. Another one is security and backup. Another one is on-demand access. Users can access their resources anytime, anywhere. Resource sharing, multiple users can share computing power. They can share storage. They can share applications. You host your application on the cloud. You give access to another person to use that your application. You store your files on the cloud. That's storage. You also share computing power. So that's it. How many of them? 2, 4, 6, 8, 10, 13 computer networks that we've dealt with. And if you check your manual, they are there. So computer network, interconnection of computers and devices for the purpose of sharing resources and exchanging information. So finally, the last slide. I know it's 10 o'clock, but this one is very fast. Nothing much to talk about here. This is not on your manual, but I feel that you need to know them. We talk about computer network. What are the components? Nodes. Nodes are any device that can be connected to the network, like computers, servers, routers, smartphones, anything that can be, we call them network-enabled device. Any device that can be connected to the network is a node. It's a node. Your fridge, if it can be connected, smart fridge, smart ACs, they are all nodes. Links. Links are your physical, which is wired, or the wireless connections that enable data transfer. There must be a link for system A to interact with system B. And that link might be wired, which is physical, or wireless. Your wireless, you have your Bluetooth, you have your Wi-Fi, you have other wireless technologies. And three, these are components. Three is, so this diagram, I did not draw, I did not do it well. What we are listing now are components of computer network. And under it, you have nodes, you have links, you have network devices, you have protocols, you have network media. So I think that components should go, shouldn't be there at all, because it's on the left, it's already listed. So network devices, you have router, switch, hub, modem. You must have been hearing all this always. Routers, they direct data between networks. You have 2 or 3 networks. In between them is a router. You have switch. Switch connects multiple devices within a network. In fact, I don't know how to explain this to you. Switches and routers are exactly the same thing. They are doing the same thing. Just the routers are bigger. Now, switches, okay, let me just turn into a famous artist. Let me just draw something. See, you have a computer. No, let me go for, sorry for taking your time, but we're almost done. Let me see whether I can get a white board and share here. Can. Let's do a whiteboard. I'm coming in just a minute. Yes, anything's on the screen. Whiteboard, yeah. Can you see the whiteboard? It's a whiteboard now. Can you see it? Okay, please don't touch it, please, so that it will enable me to draw. So let me draw small circle. Let me draw 2 or 3 computers in a network. So this is a network. Let me use another color. Red is a network, and this network is made up of 3 devices. Now, in the middle, let me use pink. This is a switch. This switch connects this, connects this, connects this. So let me draw another network. It has 4 devices, 1, 2, 3, 4. And the switch might be here, must not be central physically. Switch here, connects this. Please don't touch the screen so I can finish drawing, and connects this. Now, switches are the purple. So it connects devices in a particular network. Each network is indicated with my red line. Network inside 3 devices. The other one, network inside 4 devices. Now, see router. Router. Let me use this rectangle. It connects switches. See, it connects switches. It connects switches to form, a bigger network. So switches connects devices in a network, while routers connects switches. They are doing the same thing. They are forwarding packets. They are forwarding whatever is being sent from one device to the other. So a switch in a network ensures that a device and the other device can interconnect, can interact, while a router ensures that 2 networks or 3 networks or 4 networks can interact. So that's the big difference between switches and routers. If I'm you, after this lecture, go ahead and read more on them, routers and switches. Okay, let me close and go back to the slide. We're almost done, really done. So that's the router, that's the switch. Router directs data between networks. Switch is between devices in a network. So the hub is a basic device that transmits data to all connected devices. Modem connects a local network to the internet. So the next is protocol. Protocols, whenever you have a protocol, even in English language, it's like a rule. So protocols are rules governing communication. And network media are, it could be wired or wireless, the network media. So the wired is the cables, your fiber optics, your Ethernet cables. While the wireless signals could be your Wi-Fi or your Bluetooth. I think we've come to the end of this lecture. So I thank you for your attention, and I thank Arsenal fans for not crying too much. Their reaction today is mature. That shows what people have been saying, that Man U fans are not matured at all. They always cry whenever there is issue, just like Real Madrid fans. Okay, thank you for today. I'll be sharing the slide and the link to you. It might not be immediately because I have other things on my neck, but you surely get it. If you don't have it, if you are here now, you are hearing me and you never got the first one, reach out to your COS rep. Your COS rep should find a way to reach out to the COS 101 group, WhatsApp group they created. And that's where I place the link. And I purposely do not share the link too early again, so that you people will not knock me out of the lecture. So I always wait when I've logged in, everything is fine, and then I will share. So to the guy that said Liverpool is, London is Liverpool. No, Liverpool is not London. Liverpool is red, and it's red on its own. London remains blue. Sorry, Arsenal fans, go and drag it with Tottenham second place, and with Fulham too. But whenever you win Champions League, come so that we talk. Thank you very much, guys. All these were jokes, so don't take it too deep in your hearts. If you want to cry, you cry, Jerry. All right, bye-bye, everybody. Take care. Have a nice day.